All right, let's talk a bit about the anatomy of the periodic table. So there's this first graphic here shows us a bit about that. So there's a few different ways of dividing up the periodic table. Um, these first two and then these last five here are sometimes referred to as the representative elements, as they are here. They can also be referred to, if we were to include the noble gases, as the main group. This here in the middle can be referred to as the transition metals. Down here at the bottom, lanthanides and actinides. And let's go through in detail and talk a little bit about this. So this was actually first put together, first thorough periodic table by Dmitry Mendeleev. Notice that he arranged the elements by atomic mass, that there was a reoccurring pattern. 65 elements had been discovered when Mendeleev began, and part of what he did was to group similar properties together. The increase in atomic mass was not a perfect trend, though. So this atomic mass is not the atomic number, not the integer that's on there that we use now. This is the what he was using was the atomic mass, which is similar to the molar mass that we're using. So it doesn't put all of them in perfect order doing that. In 1913, Moseley determined the elements, in fact, should be ordered according to atomic number. So Mendeleev did a really great job of getting really close to the correct periodic table. Well, let's talk about its anatomy a little bit. So the main group elements are the ones that are shown here in gray. So it's the whole top of the periodic table, excluding the transition metals there in the middle. And then some of the columns we can name, the one here on the far right, this is the noble gases. The group in light blue there in the middle is called the transition metals, or the D block elements. And then here, sometimes on different periodic tables, sometimes zinc, cadmium, and mercury get pulled apart and get pulled out of the transition metals. We've talked already a bit about dividing this way, but this is an important way to divide the periodic table. The green here are metals. The metals and the nonmetals are separated for the most part by what we have here in purple, the metalloids, and then the orange ones are the nonmetals. It ends up, for different things that we're doing, different ways of dividing the periodic table can be useful. This is a rendering of a handwritten periodic table by Mendeleev, and I'm not going to spend a whole lot of time on this, but you can trust me that he aligns most of the elements correctly to what the way we would align them now. One of the most interesting ones was he predicted that there should be a couple of elements that the world had missed, and from the things, he did a pretty good job with this. So germanium wasn't discovered at the time that Mendeleev predicted the periodic table, and he came up with pretty close to what the properties should be. So the atomic weight, he got pretty close, the density, the color, what the formula would be of the compound when it formed an oxide, the density of the oxide, the formula when it reacted with chloride, the density of the chloride compound. He roughly predicted the boiling point of the chloride compound. When it reacted, what the structure of the ethyl compound would be, its boiling point, and roughly estimated the density of the ethyl compound. So he predicted, and this was a brave move to do, was to leave a couple of holes like this in his periodic table that were later filled when we discovered those elements. All right, let's look at some further classification. So main group we've already talked about. Some of the columns can be named separately also. We have the alkali metals. That's the first column. Column right next to the alkali metal is the alkaline earth metals. Almost all the way to the far right in green there's the halogens, and then next to them are the noble gases. Middle again can be called the transition metal, or the D block metals. And then the bottom are the lanthanides and the actinides, named after what starts them off, lanthanum and actinum. All right, and we'll talk just a little bit about reactivity. So the alkali metal, the first column on the left in the periodic table, group 1, they're silver colored, and they're very reactive with water. So here's an example of the reaction between water and potassium. And what happens here is this reaction is very exothermic, and we haven't talked about that term yet, but that term means that it releases a lot of heat. And so you have a reaction that gets really hot, and at the same time you're producing a gas which is really flammable. And so this usually starts a fire when you add potassium to water. The alkaline earth metals are fairly reactive, so we went from very reactive to fairly reactive. They react in a similar kind of reaction. So here we needed 2 potassiums because we need 2 electrons to do the reaction. Magnesium has 2 electrons, so the stoichiometry here is a little bit different, but in both cases we produce H2 gas from the reaction. Then we go to, almost all the way over to the far right of the periodic table. The halogens are also very reactive. F2 is one of the most reactive elements in existence. Cl2 is highly toxic, is often added to swimming pools to kill bacteria. And the reaction between Cl2 and H2 makes a strong acid. H2 plus Cl2 gives us the HCl. If we introduce this to water, we get the strong acid, hydrochloric acid. Noble gases, group 18, they're chemically inert. A few of them will form compounds, but it's under very, very, very harsh conditions. And so for the most part, we can say they're totally unreactive. All of these, since they're unreactive, chemically, they're nice to put into lights, and we put in a high voltage and we excite these different atoms and they all give us a different color.